So let's start. Do you remember, by the way, when the first plant stem cell extract was released on the market, on the cosmetic market? I give you a little hint. It was an apple extract. So as you can see here, it's not only the very sold products, which is taking away your wrinkle. An apple will help as well. No, it's a little joke. So you know it's an apple they may keep a doctor away. But it's probably what was inspiring Mibel in 2008 when they released first plant stem cell extract, bringing some anti-wrinkle benefit, and obviously it created a lot of buzz. You know, here just a few sentences extracted from an article in Vogue US in November 2009, where a premium brand obviously wanted to have this must-have active ingredient in the cream. Lancôme tricked the own version of the apple complex into the absolute. And at that time, it was already a recession. Still, I think we are still in the recession phase. But Lumen offered this plant stem cell extract to a wider audience. And when you are the first, obviously, there are followers. And then many companies that were already on the way released different plant stem cells extracts, either some supplier company or some big players. And it was not just Apple, because you can create plant stem cell extract from the plant you are interested in. Here it's an example with the Edelweiss. Just a little highlight on one of our products, eCollagen, which is boosting the collagen production from the top, and that bring very, very strong benefit, anti-wrinkle benefit as well. But it's not the topic today. Let's focus on plant stem cells. So obviously, when you are innovative, it's also sometimes controversial. And that's what was posted in a website, a blog. I can't believe the hype, you know, beauty product with plant stem cells. Yeah, obviously, controversial. But in 2013, Elle published an article where we were starting to talk about an interesting word, sustainability. That's what is behind plant stem cells. And in last year, in a report from this company on the focusing on global cosmeceutical products, plant stem cell was seen as the most advanced innovation to target sign of aging. But obviously, again, yes, it's an interesting area, but still we need some data, rigorous data to prove the benefit. But the interest is rising, rising, rising. So what are plant stem cells? Let's have a look on them. This is this green staining here that you see in the middle of these pictures. They are located in a tissue, in an area of the plant called meristem, and this meristem is located on the shoot and the root. And the plant stem cells are the source of growth for plant. What is interesting in plant stem cells is that basically they can be divided from an unlimited number of time, meaning that they are basically never aging, they are immortal, which is very attractive from a marketing point of view, but from a scientific point of view as well. But from a scientific point of view, why plant stem cells are so interesting? Because we can access these secondary metabolites. Sounds tricky. Let's dig a little bit in science. You know what is secondary metabolites? Yeah, that's why many of the fruits, many of the plants have color. The secondary metabolites in the plant, it's small compounds that help the plant to adapt to the environment. And you know many of them. Resveratrol, for example, in grapes, red wine. That's why red wine is so good. Green tea, epigallocatechin galat. It's one of the strong antioxidants that you find in green tea. So drink a bit of green tea, a bit of wine, not too much, and that brings a lot of benefit. But definitely these compounds own biological activity, this secondary metabolite. And obviously they have been used for centuries in traditional medicine. It's an important point. So how we build, how we create some plant stem cells. It's quite, let's say, here it's a simple view, but I will go through. So you start from a plant of interest. And as you know, and that's the power of the cells in the natural and plant kingdom. The plant have the ability to they differentiate. So you have basically you take some cells from a leaf, but these cells could turn into non-specialized cells, which we are calling de-differentiated cells. You have all made this experience. You take a little stem in the wood, you put that in the water, and after 2 or 3 weeks, you can see some roots coming out. So that's the power of the vegetal cells to de-differentiate, and in this case, to differentiate into roots. We don't want to move to roots or to specialized cells. We want to keep them non-differentiated. But they are owning the same genetic materials as the original plant, meaning that you have a small factory that will be able to produce the same active ingredient than in nature. That's cool. Pretty cool, but obviously it's not as simple. There are different steps. First, you start by growing your plantlets that you take out of the environment into a sterile environment because you don't want to have contamination. From that, you go to the step of the differentiation. Then you have this, what we call callus. It's an aggregate of stem cells. And as you can see on the picture, I will show you one much better a bit later. It's friable cells, and that you can put them in the suspension. And in the suspension, this is the production scale, the lab scale, where we are starting to get a division of cells, cells growing, and cells starting to produce active ingredient that we can extract. So we have the lab scales. If we want to grow them then, because at the end it's to produce at an industrial scale, there is an upscaling step. It's maybe not that visible on this picture, but it's basically a bag. Instead of having a flask here, you have a bag, about 10, 20, 50 liters, with your cells in suspension. So it's a scaling up. And if you want to go to production, basically you use this type of bioreactors, which could be 1,000 liters to even more. So there are different challenges. Here, just a picture to show you, some plantlets. Basically, these plantlets are coming from a plant that is initially, this one, I will not tell you exactly the name of this plant, but this plant is initially growing in this third of the south of Africa. So we adapt to make it grow in Sweden. That's cool. And here it's the stem cells, the callus of this plant. So it looks easy, but it's not, because there are many, many challenges at different steps. So first you have to work in a sterile environment. If you have any contamination, obviously bacteria will grow too fast and your culture is wasted. Some of the difficulties, it's definitely at this part, and that's the focus here. After time, you are losing productivity because there are some genetic changes that occur in the suspension. The shear sensitivity, slow growth rate, and low oxygen requirement. So all the parameters to control the growth of your cells is very difficult to handle. And at the end, what is the consequence is there is a lower content of production of complex metabolites, so the secondary metabolite that you would like to. So it's not an easy path, but does it work really? So I would like to show you here a success story that comes from pharma industry. And as we talk science, I wanted to show you a nice molecule. This is a drug, Taxol. Probably you know, it's a drug that targets breast cancer. And it's, obviously there is a big, big turnover behind that. It's, I think they reached $1 billion turnover in 1992. So today I don't know how much is the volume, but obviously there were a big interest behind this drug. And at that time, so it was in 1992, the global need worldwide of Taxol were about 25 kilograms per year. So and to get that, because Taxol was extracted from bark of these Pacific yew trees, to get the 25 kilogram, that was needed. 340 tons of bark, meaning that they had to cut about 40,000 trees. And you know how long it takes to have adult trees. It takes almost centuries. So it was not really sustainable. Yeah, chemists made some job. But again, yeah, you imagine, very costly. Many steps, many not nice solvent and organic reagents, so definitely not a solution. And today, the need is 10 times more, because Taxol has been, different use has been found, so targeting breast cancer, but obviously different over cancer. So the way to produce is thanks to plant stem cells technology, and today the production is based on 75,000 liters bioreactors. It works. Obviously, the business behind that was huge, so there were a huge investment to reach that possibility. Is it worth to do it in cosmetics? Yes, I think it is, definitely, otherwise I would not be here. Because there are some solutions to boost the production of the metabolites. As I said, one of the limitations is a lower level of secondary metabolite productions. So one solution is called the elicitation. So you can find a way to stimulate your plant stem cells, to produce some of the active ingredient you would like, so the same that they are producing in the environment. Because obviously in the environment, the plants are reacting to the environmental pressure. So you need to find a way to create a stress, to make them produce these actives. And one of the ways by using these compounds, they are plant growth hormone. And then you can have different, depending on the concentration, the time in contact in your culture, you can get some interesting results. And that I would show you one graph of data. It's an assay that we measure the antioxidant properties. So meaning that our positive control is a green tea extract. As I said, the epigallocatechin gallate is one of the best antioxidants known. And basically, so the lower is the value, the better is the antioxidant activity in your extract. So that's our positive reference. And as you can see here, there are different plant stem cell extracts that we have developed based on different type of concentration and so on. And we have three that looks quite interesting because this one is quite close here. So this condition of culture of this plant stem cell extract is probably interesting, and it brings a strong benefit in terms of antioxidants and closer to green tea. Another way, which is even more advanced, it was published already a few years ago in Nature Biotech, is to use these cells, the cambial meristematic cells. I talked earlier about some cells, the real stem cells are located in the meristem, and we are doing dedifferentiated cells. So that's the difference. So here it's the path I talked about. Here is selecting specifically the cells that are in the meristem, growing them, and having this, what they call CMC culture. Does it work? Here it's extracted from this paper. Again, it's related to Taxol. It's called paclitaxel or Taxol. As you can see, with the dedifferentiated cells, either they come from embryonic or from needle from this tree. With the elicitation, you have an improvement, but with this CMC, so taking the specific real stem cell from this tree, you can really boost the production of your active ingredient. And it's even more interesting here on this graph, because here it's how much is released in the media. Here, little, so basically the active ingredients stay in the cells. In this case, it's released in the media. So imagine the amount of energy to extract the ingredient from 300 and 400 tons of bark to get this extract, and compared to having it released from the media. The extraction process is really simple, consuming little energy. And that's one of the core benefits. And you have it produced, you can control the production. So where I want to go, it's basically to show that, yeah, plant stem cells are delivering strong benefits regarding to the sustainability aspect. You can basically almost cultivate any type of plant growing on this planet, meaning you have access to most of the plant, where at the same time you are not compromising with the biodiversity. You don't have to cut 40,000 trees. You don't need lands. You are not dependent from seasonal or geographical variation. We are growing a plant growing in a desert in Sweden, which is cool. You don't need any pesticides, any fertilizer, and so on. You don't need that much water. You need a bit of energy as well, but little compared to what's happening in the environment. You can produce locally, basically, and as you control all the conditions, you get some very pure extracts. Again, why going in that direction? Because it's nice, it's sustainable, but it's fun to be sustainable today. But is it just fun? Let's consider our planet and consider some facts. So, today, someone said that there is about 8 billion mobile on the planet. So today we are a bit less, so maybe people have several, but some people have several mobile sometimes. So, but today, yeah, we are about 7.1 billion people on the planet. And as you can see, it's during the last 2 centuries, we have grown by 6 million. It's huge, huge increase and huge pressure on the environment that we know. You know, this global warming is not a mystery. And what is interesting for us is that our life expectancy has increased by almost by the double. This is global number, just not in the well-developed countries. It's globally. 35 in that time, now it's 67 years. So we are more and more people living longer. Great for us, but the planet is suffering even more. So how we deal with that? Because the first need, and that's some projection from the UN, in 35 years we will be more than 9 billion. So the agriculture first need to feed. How we will feed the world? That's a very, very big question. And some of the calculations, some of the projections say that from now to in 40 years, our global food production must increase by 70% and the cereal production by 42%. So the pressure on the environment will be even bigger. Scary, no? So, coming back to the secondary metabolites, they have been used for traditional medicine, and they are coming mainly from plants. So there will be a big competition on first feeding the people, plus giving the people this solution. Because let's listen to this guy. He's a specialist in traditional medicine. And what does he say? Today, 75% of people are relying for their primary healthcare needs on this traditional medicine, meaning on these secondary metabolites. And remember, the population is aging, so healthcare needs will be even bigger. And not just the traditional medicine, it's also 60% of our anti-cancer drug are from plant origin. So, let's come back to these people. Because we have a big population, but this population are, as you know, and we have heard a lot today, how to target the consumer. These people are basically 7 billion consumers, and these consumers have thoughts, they have aspiration. That's where some of them are creating the trends. Some of them are following the trends. And what are the trends and mainly on skincare, how they feel about natural. So today, definitely green is becoming the new black, especially in skincare. There is a demand of green compounds. What does it mean, green? Green is, let's see some numbers. They come from here, a survey from data monitors. It's how the consumer who says that green and sustainable production influence their personal care purchases. Globally, 1/3 of the population. Let's look the number of these, as we said, so-called developed or very developed countries. France, people don't care. Sweden, but not really. Britain, UK, okay. Germany, oh, maybe a bit better. Italy, okay. So Japan, not that much. US, okay, fine. It's not the big focus there. But look at this country. Russia, India, China, I'm confusing with the flag, Mexico, Brazil. It's more than about 50%. And it's basically where the population is, and the population is growing. There is a more and more bigger concern in this country. Let's continue. Natural ingredients. How much natural ingredients claim or containing natural ingredients will influence the people purchase? Very high to high, it's more than 50%. There is a very big focus on getting natural ingredients in products. Not only that, about these people, the shoppers, that about 70% of the skincare shoppers consider that it's better for their health. So it's good for the planet, but it will be also bringing some benefit to them, better for them, meaning that they are ready to pay more. Obviously not be fully charged, but pay an extra to get these premium natural ingredients. And today also there is a trends growing about called re-enlightenment, meaning that science is becoming definitely trendy, which is fine for the scientists maybe. But yes, science will be, or seems to be, the area where there will be some solution to take care of some of the big problems that we will face. And definitely regarding this field of skincare, today there is, very much trend around multifunctional skincare. We don't want people don't want a skincare that target your wrinkles. They want more. They want multifunctional benefit, and science is helping to deliver that, and especially to deliver effectiveness, because again, it's come from a survey where loyalty have been measured. What is the main loyalty driver when we talk about the product? Brand image is very important, 30%. Price, coming quite high. Yeah, not. But the most important is product effectiveness. People want to pay for something that works. And if you want to show that it works, we need to prove that. So we need to do some testing to validate our driving loyalty, which we want, keep our consumer attached to a product. So I'm close to the end. And I talk about the planet, and so let's take a bit of distance again. We are on the moon here. And as you know, some people, as we are more and more on the planet, some people want to escape. Some people are already thinking they want to live outside the planet because probably it will be better. But it's in the mind from many people. But to live outside of our planet, where basically there is nothing today here, but we need plants, we need animals, because we are getting a lot of materials from them. So would it be something real? But no, obviously, we will not bring any cow or any silkworm or tree to Mars. We have to find a solution if we want to live on another planet. And basically, instead of taking a full organism, there are now we have heard about Mink, so maybe we can ship Mink, this 3D printer color ladies, onto Mars. But definitely that's in the mind of many people. 3D printing is growing like crazy. And here there are some people thinking to create an array, meaning that you combine the stem cells with a kind of biopolymer, making the production that you want. Okay? And it's not just for fun, it's a project which is funded by NASA. And that was released at the beginning of this year, and this is how it was written. I think it's really a cool title. How NASA will print trees. So that's the future. So if we can do that somewhere in the planet, so we can start doing it in our planet. So overall, if we consider the different aspects, it works basically. There is many sustainable aspect benefit. Obviously, it's not an easy path, but I think there is a big needs because of the state of the planet if we want to be a sustainable business as well. Considering the trend and what's happening, yeah, definitely plant biotechnology and specifically plant stem cell technology, I make the difference because there are a lot of research in this area. You have heard about algae, microalgae. So there are many solutions growing. But definitely, it's still a science which is at the beginning. But we are definitely at the beginning of something really exciting. And I just would like to make a little connection with Rome. This is the way the agriculture was done 2,000 years ago. It's still the same, basically. It's maybe a bit more mechanized, but there is not that much change. So the way we move on to the plant stem cell, I think there is definitely a clear revolution on the way we'll produce natural products, and specifically for cosmetic ingredients, natural active ingredients. Grazie mille. It's coming. Yeah. Thank you very much.